Hello, this is Dr. Bradley Wright with the presentation on the brain for you youngsters. You guys ready? We're going to start off with the neuron. The neuron is a long, thin cell along which the brain transfers messages to other neurons, muscle cells, and or gland cells. The neuron is the basic unit of information processing, and it's the building block of the brain. It receives stimuli and it will either pass it on or it will choose not to pass it on, neither of which is more important than the other. Now there's different parts of the neuron. First are these tree branch looking things on the outside of the fat part. Those are called dendrites. Dendrites are a branched extension of the neuron, and they sense other neurons and they receive messages, and then they send those messages into the middle or more fat part called the soma here. The soma, or the cell body, contains the nucleus. And that takes in the information from the dendrites, and then it decides whether or not it should send the messages through the axon to other cells. The axon is an extension that carries the electrochemical signal away from the soma. Now those can be as short as a nose hair, or as long as your whole body, because some of them go from your brain to your feet, and some of them go from one little neuron to another little neuron. Next is the synapse and the synapse bulbs. These are little areas that send messages into the dendrites of a new space, and it's also the space between the end of the axon and the dendrite. Next, we have the firing of the neuron. These dendrites receive excitatory and inhibitory signals, and the soma takes them together and sums them up. It really calculates the way it goes, and if it's excited enough, it's going to send it off to another cell, and the brain function is going to keep passing on until it gets where it needs to be. If the inhibitory signal is stronger than the excitatory signal, then it won't fire and it'll stay still. If not much signal is going on, it'll go into its background state and fire slowly and weakly. Now we're on to the nervous system. The nervous system is what most people will call just the brain. The brain, or the nervous system, controls emotions, movements, thinking, and behavior. It's divided into two main parts, the central nervous system and the peripheral nervous system. The central nervous system includes the brain and the spinal cord, and it's the most major part because it has the spinal cord, which carries the majority of all the messages that your body wants to send through itself. Next is the peripheral nervous system, and these have smaller branches of nerves that reach other parts of the body, and they're divided into two major categories, the somatic and the autonomic nervous systems. The somatic nervous system is part of the peripheral nervous system still, and it controls voluntary activities. Kimbo Slice thought in his mind, I need to raise my arm and strike this other guy in the face. He did that all on purpose, and that was all voluntary activity, so it was part of the somatic nervous system. This baby says, I need oxygen, but he didn't really think that. Some part of his brain did. He didn't consciously think that, is what I mean. He unconsciously thought that, and it was involuntary. He couldn't control it. He had to breathe. So that was his autonomic nervous system, or autonomic. And now we're into the brain's physical breakdown. It's broken into three main systems, the central core, the limbic system, and the cerebral cortex. The central core controls basic life processes like breathing, pulse, arousal, sleep, and it's broken down into five more categories: thalamus, pons, cerebellum, reticular formation, and the medulla. And then we move on to the limbic system. The limbic system exists only in mammals, and it regulates motivated behaviors such as emotions, memory processes, regulates body temperature, blood pressure, and blood sugar, and it's broken down into three more categories: the hippocampus, amygdala, and the hypothalamus. I am an expert, but my tongue doesn't work very well. It's part of my central system. I can't speak, so I'm sorry about that pronunciation. And now I'm on to the cerebral cortex. This controls higher cognitive and emotional functions, and it is made up of 4 different lobes. First is the frontal lobe, and this is why we're not allowed to drink till 21, because it's not actually done developing till 25, and we think it's okay to let it slow down our own development at 21 if we make the decision. And that really involves our motor controls, planning, decision making, so it might be a wise decision to not drink until 25, but we'll also probably make the less smart decision to have more fun and drink before 21. Who knows? Next, we're on to the O lobe. I still can't speak, so I'm not going to try to pronounce it. And this is where the eyes send all the messages that it has to the brain. This is the visual information lobe, and it'll send its information either to the P lobe or the temporal lobe. P lobe, again, I don't want to pronounce it. It does sensory processes such as spatial interpretation, attention, and language comprehension. That is where we become genii or non-genii. And I didn't have room on the last slide for the temporal lobe, but it deals with auditory perception, language comprehension, as well as the P lobe, and visual recognition. Finally, we're on to left versus right brain. The left brain, in my picture you see, looks like a computer screen or a computer circuit board because it has a lot of logical, funless thoughts. It's not the most pretty, exciting stuff, but it's logical. It builds up. It deals with verbal, mathematical, and analytic thoughts. And then the right brain is just the opposite. It deals with nonverbal thoughts, spatial, and holistic messages and signals is what I really mean by thoughts. And that's what we're going to understand our music and our art and see beauty in. And that's the best way to understand why rappers are good, is if you have a rap brain, is going to be the right brain. Rap, right, art, beauty. Right brain. Left brain, logic, and that's how you're going to remember it, folks. We're on to my works cited. I obviously did a ton of research. Thank you guys for listening, and have a great day.